The clicker works. Okay, so first a little bit about me. My name is Jack Servia. I'm a developer relations engineer at O1 Labs. O1 Labs is the company that built the proof system for the Mina protocol and also the reference node implementation. We're one of a couple of organizations that are working in the Mina ecosystem. Another major one is Mina Foundation. This is kind of like the Ethereum Foundation of Mina. And we have a few other organizations that we'll talk about throughout this presentation. I'm based in Denver, Colorado. I was born here. I still live here. I'll probably always live here. And that's my Twitter. So, okay, I think these are backwards. Let's see. Oh, God, I had the clicker upside down. Okay, so here's our agenda. First, we'll talk about Mina. Then we'll talk about SnarkyJS. This is the smart contract language for Mina. We'll talk about some use cases. Then we'll talk about zkIgnite, which is a really cool program that's helping get people started building things on Mina, and some next steps. And finally, we'll have a QR code with all of the resources from this presentation. So you don't have to worry about taking any kind of notes or anything. You can get the slides, links to Discord, whatever you need later. So what's Mina? Mina is a layer 1 blockchain that proves its entire finalized state using recursive zero-knowledge proofs. That's kind of wordy, but the idea is pretty simple. Other blockchains work by taking a bunch of signed requests and basically doing them all in public and sort of summing these requests together in order to get the current finalized state. This is cool because it means that you can have verifiable computation, but the problem is that it relies on everybody being able to see everything that's happening, so privacy is hard, and it also requires that you remember the entire history of the blockchain. So it becomes increasingly difficult to decentralize over time. Mina works fundamentally differently. It's 22 kilobytes, and it will always be 22 kilobytes. And the reason why is because it uses these things called recursive zero-knowledge proofs, which are basically zero-knowledge proofs of zero-knowledge proofs, in order to stay the same size. So we can have a zero-knowledge proof that represents everything that's happened on the blockchain up until this point. Then we can do some more stuff, and we can prove this too. And then we can verify this proof for the last state of the blockchain and all of the new transactions that we've done, and we get a new proof. And then we can forget about the old proof. So we only need to store one proof in order to know that what we have is valid. So this is super cool. It was really hard to build, and it's also super useful. So Mina offers some major advantages over conventional blockchains. Privacy, scalability, decentralization, bridging, and oracles all kind of can work a bit differently than you might be familiar with, and so we'll talk about all of that now, starting with privacy. Most blockchains run smart contracts on every single node, so the interactions are inherently public. This is an Ethereum transaction. We have a request. We want to call some update method and pass in X and Y. The result is that every node in the Ethereum network runs this update transaction. They do it publicly. They can watch each other. This is where the security comes from. But Mina smart contracts work different. They run in the user's browser. They're literally written in TypeScript. And so the execution is private by default. You run your code yourself. You don't send anything about it to anybody. You just send a proof that says that you did it correctly to the Mina nodes. You can see what this looks like. If we want to call an update method in a zk app, pass in X and Y, what we get out is, we run the method ourselves, and what we get out is a list of updates and a proof. So the Mina network just verifies the proof, and then if the proof is valid, it adds the associated state updates. This is really cool for privacy, but it's also really cool for scalability. Mina doesn't need a gas pump. Because the apps run off-chain, the transaction cost is totally independent of computation. In fact, you can do a literally unlimited amount of computation in a single Mina transaction, and it will cost exactly the same amount as it would cost to do, 1 + 1. So this is cool. But what if you want to build an application that requires a lot of transactions, not just sort of heavy transactions, but many transactions? This is possible using recursive zero-knowledge proofs to build these things that we call application-specific rollups. And what these basically are is, let's say I have a game. People want to play the game, but we don't want to make people wait for blocks to be mined or to pay transaction fees every time they make a move. What I can actually do is prove my move to you, send it straight to you. You can verify your move and you can verify your move and verify the proof of my move, all in your proof, and send it back to me. We can do this back and forth. The proof stays the same size. The thing we're exchanging doesn't grow at all. And then finally, we can pass this, into a smart contract method on Mina and verify the state of the whole game. So we can build applications that need Web 2-like performance with Web 3-like security guarantees. Very cool. Usually, scalability and security come at the cost of decentralization, but it's not so in this case. because the entire Mina state can be verified using only a single zero-knowledge proof, almost any device will be able to connect to the Mina network directly. That means without connecting to like an RPC endpoint or Alchemy and Fiora or something like that. We have another team in the ecosystem called Viable Systems, and they're building something called Open Mina right now. In fact, there's a demo of it that you can find in the QR code at the end of this presentation. What this is it's a full Mina node that runs in the browser. So you can see setting up browser for web node, getting ready to verify blocks, connecting directly to the Mina network, and then catching up to the network. And so you can actually send a transaction straight from your browser with a full node. Granted, it's a full node only for your account. It doesn't store the state of other accounts, just yours. But if you want to transact with somebody, they also have that information for their account. So yeah, you can check this out later. It's very cool. Another thing that works pretty differently, right? So if we can verify the Mina state in a web browser, maybe could we verify it in a smart contract on another blockchain? Yeah, in fact, we can. We can write a smart contract on another blockchain, like, for example, Ethereum. And this can have a method that we pass in the Mina zero-knowledge proof to. And if the proof is valid, right, we can verify the proof using some predefined routine that we can implement in the logic of this Ethereum smart contract. And if everything checks out, then we can bridge the entire Mina state over to this blockchain without having to lock any sort of capital, without having to sort of introduce any additional security assumptions, without any kind of lag, and without any kind of permission. Anybody can call this method. And another organization that's working on this, sort of in the Mina ecosystem is Nil Foundation. So they have a demo on their website right now of, in EVM Mina state verification, just what it sounds like. So we can grab our relevant data from the Mina blockchain, and anybody can do this. Then we can pre-process it into a proof that's more efficiently verifiable on Ethereum. This is just gas optimization. This is what the output looks like. This takes maybe 1 minute on a MacBook Pro. And then we can connect to MetaMask, and we can send a transaction. In this case, it's to Polygon. But, the result then, after this transaction is mined, is that the whole Mina state is available on, in this case, Polygon, but whatever blockchain you're running this smart contract on. This means that Mina can kind of act as its own L1, but also sort of as a rollup for other blockchains. Okay, very cool. But what about oracles? SnarkyJS smart contract methods can accept and validate signed data. They can do it really efficiently. We have some cool stuff built into the proof system to make this work. And this is unique because it means that you can ingest verifiable data privately. So you want to do something like prove that you qualify for a loan without disclosing your whole financial history. You can do that with Mina. It's also really cool because you can ingest a lot of data. Because the smart contracts run off-chain, right? Sort of in Ethereum world, we think of an oracle as like a thing that stores a value for the price of a pair or something. But for Mina, we can dump pretty much as much information as we want to into a smart contract and do as much stuff as we want to it. We actually have somebody in the community who's built a JSON parsing library for Mina. So in theory, you could pass, a whole JSON object into a Mina smart contract, parse it, get some sort of insight out of it, and then prove this. So you have access to sort of a different kind of richness of data than you would on most blockchains. Finally, in the future, this isn't available yet, but we're working on something called zk oracles right now. And so these other oracle models require somebody to sign the data, and so you have to trust somebody to sign it. Now, usually this can be the data provider, so it's not a huge deal. We have something called the Mina signer that makes it really easy for people to sign their data in a way that Mina can really efficiently verify. But in the future, we want people to be able to pull data from anywhere and do so in a verifiable way. And so already, when you interact with something on the internet, you're probably doing it through an HTTPS connection. And there's a way, using some fancy cryptography and MPC stuff, that we can take this proof that really is only compelling to the two parties involved in this handshake and make it compelling to everybody and in a non-interactive way. So what this means for users is that you could do something like go to, I don't know, the New York Times website, highlight the results of a soccer game, and then just bring this on-chain. And what you get is a proof that says, hey, the New York Times said at this point in time that this was true on this web page, basically. Okay, so that's Mina. Now let's talk a bit about SnarkyJS. This is our TypeScript library for defining zero-knowledge proofs, and it's also the smart contract language for the Mina protocol. It looks sort of like this. You can see That means this is a real smart contract. It's all in TypeScript. It's not a transpiler or anything. It literally runs in the browser completely. It's a package that you install and you're good to go. Everything is in TypeScript, so you can keep using the tools you're familiar with, like npm, prettier, ESLint, VS Code. And it's very easy to learn. You can see we've done a pretty good job of making the type doc coverage really good. So of course, if you want to get started, you can watch videos, presentations like this. We have tutorials and good docs. But what you can also do is just jump into a code base, and if you run into something you don't understand, you can hover over it, and we'll probably have the type definition, plain text explanation of what it does, and an example. Okay, so it's incredibly powerful, and we don't have enough time to dive into it here. But I've given a lot of other presentations about it, and there will be a QR code at the end that links to them. So if you want to learn more, if you want a more developer-focused, sort of presentation, you can check that out. All right, now let's move on to use cases. We're going to start with something called proof of alpha, just to kind of give you an idea of what's possible. Proof of alpha is an application that we're building internally, just to kind of test things, and because we thought it would be fun. What it is it's a service that you can use, and you can dump your trading history into it, your order history from an exchange like Binance or something, and we can calculate your performance, your cumulative profit loss, and then we can create an attestation to this without revealing the specifics of your transaction history or of your order history. So you can do something like, I don't know, put this on your Twitter and prove to people that you're really good at doing crypto. So, okay, how does it work? Well, users can query their order history directly from their API. From their exchange's API. So, like, right, Binance gives you an API. You can get a read-only key, and you can pull your trading history from it. And then you can pass it into a SnarkyJS smart contract. And SnarkyJS will check that the signature for the data is valid. In other words, that the data really did come from Binance. And then it will compute the cumulative profit loss and send this on chain. And so everything happens on your own machine, right? When you get the data from Binance, you're really doing this in your browser on your own machine. Mina's not doing it. Another service is not doing it. Then you do the computation on your machine, and you prove that you did it correctly. And what you get out then is just a value that's how good are you at doing crypto, and a proof that you calculated this value correctly using real data that was from Binance. So this is awesome. The Mina network will never see your order history or really anything else. It just sees proof that you calculated it correctly and the outcome. Okay, so what else is possible? There are a couple things. DAO voting is pretty interesting. We can build private voting. That's cool. People are interested in that. But we can actually also build super, super, super high performance voting. Basically as many votes as you want at basically no cost using this application-specific rollup model. We can do blind auctions. I think these are pretty interesting. There are some unique kinds of auctions that people have explored within the Mina ecosystem. Simple things like Vickery auctions, but people are getting real creative with it. I haven't had time to kind of dive all the way into all of them. But it seems like there might be some really interesting auction mechanisms. And then finally, decentralized exchanges. We have an example of this in the SnarkyJS example folder in the repo now. But there's kind of a lot that can be done here too. It seems like there's ways to make exchanges that are pretty nearly immune to any kind of miner extracted value. There are probably some other creative things you can do. I don't know if this is a good idea, but right, with Mina, you can build programmable state channels. So you could maybe build something like Lightning Network with an exchange in it. It's probably a bad idea, but it's interesting. And kind of the idea behind giving talks like this and stuff is that all kinds of things are possible. We're really focused on building kind of like the foundation layer of this new kind of like platform that people are going to be able to build completely different kinds of applications than they have been able to build before on. And so we're pretty, we've got our hands pretty full building the sort of the foundation, but we're really excited to see what people build on top of the foundation. There's lots of cool games that are possible. Obviously, you can build games with limited information, but you can also build games that rely on sort of provably fair, procedurally generated worlds. You can build games that require huge amounts of user interaction in order to sort of be playable. there's a lot of really interesting stuff, for verifiable credentials, even for just sort of like proving that you're running some kind of routine correctly on your, I guess, like Web 2 infrastructure, so to speak. You can do something like prove that you've correctly calculated a moving average of a bunch of values for an extended period of time. So if you have any ideas, you should come talk to me after. I'll hang around, or if you have any questions. Otherwise, we can jump to zkIgnite and some next steps. So if this is interesting to you, you should totally join zkIgnite. We're doing cohort 1 right now. We've got about maybe a week and a half left where you can sign up for it, I believe. We have a pool of 500,000 USDC and 500,000 Mina tokens. This program is sort of governed in a very interesting way. The community is in charge of it. It's not Mina Foundation or Owen Labs that's kind of steering this thing. It's the community. It's the people from cohort 0. And so if you're a developer and you want to build like crypto stuff, you can do that, and you can probably get a grant for it. If you're somebody who wants to make a user-facing product and take it to market, we can help you with that too. We have relationships with VCs and stuff. And if you want to build educational content, that kind of thing, all of this stuff is right up our alley. Okay, here's a QR code with some resources. We have all the documents from this presentation, some stuff to next steps, Discords. If you are interested in kind of picking up on this later, definitely jump into the Discord. There's a channel called ZK Apps Developers. It's really good. And yeah, if you would like to hear anything more, come talk to me after. I think we finished maybe a minute before. Cool.
All right.